Hi everyone, in this video I'm going to walk through something really similar to what I did in my last video. I've given a specific x and y coordinate. I haven't named my t value, but I think it's kind of hard to see in this. I have shown you what it looks like. In this case, t is starting from 1, 0 and going all the way around to our point. So it's almost all the way around. It's almost 2 pi, but not quite. So what I want you to do in this one is use our symmetries across the x-axis, across the y-axis, and then from these 2 points, either one. And then down below, I want to do symmetry across y equals x, and then use across the x-axis and the y-axis. Probably couldn't see that. Symmetry across y equals x puts us here. And then you can flip across the y-axis, the x-axis, the y-axis. So the points might not look perfect, but I was trying to give you a little bit of a visual guide of what I was looking for in this one, just as a warm-up with the symmetry practice. So if you're feeling comfortable after the last video, I would love for people to pause and work through this one on their own and then check. Okay, so if I'm picturing that t, and hitting this thing, is almost all the way around the circle, let's first go across the y-axis. So this point right here. I'm sorry, that's the x-axis. Let's first go across the x-axis. This point has the exact same x value as my starting point, and it has the opposite y value. So there are the x and y coordinates of the point. For the t value, this is going to get kind of messy since our t is so big. Our original t is almost all the way around the circle. If we flip over the x-axis, it's still going to be almost around the circle, almost all the way around the circle, but it's going to be in the opposite direction. So pretend that's on the outside. So this point is associated with minus t as its arc length, opposite of t. So we go all the way around, but in the opposite direction, and that should land us there. You could also use a 2 pi minus t. What that would actually give you is this little positive arc length right here. If you took 2 pi and then subtracted off almost all of 2 pi, you'd be left with this little tiny arc length right here. And that's equally correct. It lands you at the right point. It's just a different way to get there. So almost all the way around backwards or just a tiny little distance forward would both get you there. Let's start again with our original point and now flip across the y-axis. So we would land right about there. And that point would have coordinates negative root 15 over 4, so opposite x value, and it would have that same negative y value. Okay, getting here, let's see. So we could start from here and we could go almost all the way around backwards. That would work. What else could we do? There's probably another one. That's the one that's standing out to me right now. Oh, well, I guess it's still this point, so there's 2 ways to get here. So you could go pi minus t, or you could go negative pi minus t, just depending on what you want to look at there. So if we go negative pi minus t, so that there's no turning around, you would go all the way around this way, and then almost all the way around again. So you go halfway around and then almost all the way around. That's a negative pi minus t. If you went pi minus t, what that actually looks like is just from here to here. So pi minus a t, these two cancel each other out, and you're just left with this distance right here. So from here to here is pi minus t. So that one's actually a little nicer to draw, but sometimes a little more confusing to people. Okay, what color? Green. If we then take this point and flip up, or take the blue point and flip across, we get negative root 15 over 4 positive 1/4. And to get to that one, we could go pi plus t. So again, I think a really good way to say this to yourself is t is almost all the way around. So from here, almost all the way around, that's t. But to get here, I'd have to go plus or minus pi in the first place. So again, we have the choices. We can go plus pi and then an additional t. So that would be the round and round, similar to the orange one I showed. we could also do a minus pi plus a t, and this back and forth would cancel out, so that's really just this distance right here. That's a minus pi plus t, or a t minus pi, you could say. So either one of those would be good for that final point. Okay, so again, my goal is that you can spot this symmetry across the x-axis, y-axis, y equals x, and get all sorts of point information based on that. And then the next step we'll get with this is, once we figured out where we're at, what our coordinates are, can you tell me the value of sine or cosine or secant or cosecant or any of the 6 trig functions? Okay. So let's try to do some y equals x symmetry. If we're doing y equals x symmetry, this one's sometimes kind of weird for people to spot. The point root 15 negative 1/4 will end up at negative 1/4 root 15 over 4. It switches your x and y coordinates. So that's this point right here. So this is negative 1/4 root 15 over 4. Okay, and then in terms of t values, again, what we started with, hard to see in this, but what we started with was t being almost all the way around the circle. So this one looks like it's starting from here. If you go almost all the way around the circle, you end up here. So that's a pi over 2 minus a t, or you could do a negative 3 pi over 2 minus a t. You have choices, but I'm going to do the pi over 2 minus t. Remember, again, when you do that change in direction, it's wiping each other out. So if you go pi over 2 minus, you're starting here. This part's all gone. You don't have to go back and forth. You just ignore it. And you're really just going around here. So this is what you end up doing if you take a pi over 2 minus a t. Okay. From there, we can switch back to symmetry across the y-axis and the x-axis. So let's see, if we flip across, I shouldn't be so tired. If we flip across the y-axis, from here, we'll get a positive 1/4 as our x-coordinate, and we'll keep that exact same root 15 over 4 as our y-coordinate. Arc length on this one, if we start here and go almost all the way around, that's a positive t. Okay, so if we did pi over, now what I'm doing, pi over 2 plus t, yes, that looks good. That's one option. You could also do a negative 3 pi over 2 plus t. That one's kind of nice because really all you're left with is this. It's a little trickier for people sometimes, but if you go negative 3 pi over 2 and then you go plus t, by the time you've gotten back here, you've just canceled out everything you've done. So really all you need to do is go from here to here. So that was negative 3 pi over 2 plus t, or t minus 3 pi over 2, you could think of. You can think of these as rotation as well. If t lands you down here, if you go backwards 1, 2, 3 pi over 2, it would land you here. So you can use whatever you want as your point of reference. We know t gets us here, starting from 1, 0 to here is t, and we could subtract the 3 pi over 2 to get that exact same distance. So if you like that better, go for it. Or starting from here and adding pi over 2 is a quarter rotation, so it would put your point up here, quarter the way around the circle. Okay, what color next? Blue. So if we go from here straight down, that's going to have that same x-coordinate, negative 1/4, and now its y-coordinate is going to be negative root 15 over 4. So those are the coordinates of the point. In terms of t value, again, whichever way you want to think about it, I would say I know that starting from here, I could go all the way, almost all the way around and land on that point. So that's a negative pi over 2 plus t, or a 3 pi over 2 plus t. If you do the negative pi over 2 plus t, that first little jaunt cancels each other out, and then you just end up going like this. So that's a negative pi over 2 plus t. Or again, you can think about taking, this was t, starting from 1, 0, and going almost all the way around. You could think of subtracting pi over 2 off to put you a quarter of the way back toward 1, 0. either way. So negative pi over 2 plus t or a t minus pi over 2 are the same thing. Last one, this one right here. Let's see, so I think I'll do flip across here. So I get a positive 1/4, and I keep that negative root 15 over 4. And then in terms of t values, it looks like if we start at the bottom and go backwards almost all the way around, we'd land here. So that's negative pi over 2 minus t is one of the options, negative pi over 2 minus t. You could also go 3 pi over 2 minus t, and that one's kind of nice because you just get this little segment right here. You can see that the t minus 3 pi over 2 and flipping across would give us the bottom one, which we're saying is negative 3 pi over 2 minus t, and that's a good sign because those are actually opposites, t minus 3 pi over 2 and 3 pi over 2 minus t. Okay, so the negative pi over 2 minus t, let me draw it really quickly. Where was that one? That was going, we went around a lot. So we went down to the bottom, and then we went almost all the way around again. So we went more than a full lap around the circle to do it that way. Once again, if you'd like to start from one of our known points, we know t puts us here. I don't know if I think that one's quite so easy. I think that's a little tricky from t. We could go from this one. We could add pi. That's actually pretty easy. We know where we are here, so add pi. From this one, back to yeah, I think it's actually a little tricky from that one. Okay, hopefully that one went well. Thanks for watching.